Hello everyone, welcome back to my channel Physixopedia. Thanks for watching my videos and please subscribe to my channel and share to your friends. Leave your comments in the comment box. So we have started discussing about semiconductors. I have already made 2 videos on semiconductors based on the basics of the chapter. So we are going to discuss one more basic topic about the chapter. After this, we are going to see the major topics of semiconductors. So let us not waste our time, go into the topic. Today's topic is energy band theorem. Energy band theory. So what is an energy band theory? So let us go into this. We have learned that every atom possesses a fixed amount of energy about any orbit, right? That means each orbit is possessing a fixed amount of energy. When I am talking about first orbit, the amount of energy of the first orbit is minus 13.6. When I am talking about second orbit, the amount of energy that second orbit possesses is minus 10.4. So therefore, the electrons which are revolving in the respective orbits possess the same amount of energy, right? So all electrons in this orbit possess the same amount of energy. All electrons in this orbit possess that amount of energy, right? So the amount of energy possessed by all electrons in the orbit is constant. This is what we have learned from the Bose theory. So let us apply the same theory in terms of solids, liquids and gases. What happens we will see now. When I am talking about gases, gases has one nature or a property that whatever the volume you give, gas molecules will occupy its volume. So if I have taken this volume of cube, if I leave 2 molecules, these 2 molecules will move around randomly and occupy the whole space. Don't think that molecule size will be increases, but the molecule will move randomly and they will occupy the whole space, right? So this is what the nature of a gas. So when I am talking about gas molecules and gas atoms, so what you will observe, gas molecules are moving at far distances. The distance between interatomic space of a gas molecules are really more. Therefore, no 2 atoms will come into contact, right? Therefore, each electron in a particular orbit is fixed. So these 2 electrons is possessing same amount of energy. Even this also, right? So as like this, even these electrons also possessing same amount of energy about their fixed orbits. This is what we have learned from the Bose theory. Now let us look about gas. After gas, let us look about liquids. When I am talking about liquids, the interatomic space between the liquids are not that far as the gases, but still they are somewhat far compared to the solids. So let us see this. So when it comes to liquids, still the interatomic space between the atoms are more in the sense compared to solids I am taking. So there is no contact between the 2 atoms, therefore the energy possessed by all electrons in the valency is fixed. That means whatever the amount of energy this electron possesses, the same amount of energy this electron possesses, even the same amount of energy this electron also possesses. This is what happens over here also. So therefore the amount of energies of all electrons in a fixed orbit is constant. Let us apply the same theory into the solids. When it comes to solids, we know that in solids, interatomic space is really less. Atoms are very tightly packed to each other. Therefore, 2 atoms will be merged, right? So the outer layer of one atom and the outer layers of other atoms will be merged each other. In such a way, atoms are arranged in the solids. So what happens? Let me draw. So this is what happens. So when it comes to solids, the outer layers, which are nothing but valency bands, which will be overlapped with each other. So the two atoms over valency bands will be overlapped with each other. Therefore, there is a problem. So let me look about the electrons now. So I am talking about these three electrons. These three electrons are the part of this atom. So let us look about this so-called particular electron. This electron is having energy because of this nucleus, right? It is possessing potential energy plus kinetic energy, and because of this nucleus. But as the outermost layers of valencies are merged over here, if you look at about this area, this electron now comes into even the influence of this nucleus. Right? So therefore this electron is experiencing influence at a time by two nucleuses. Therefore the amount of energy this electron possesses will be different than these electrons. Because these electrons are experiencing a force due to only this nucleus. But when it comes to the electron of this is experiencing two forces at a time due to these two nucleuses. Therefore the amount of energy that electron possesses is different, right? I hope you understand. So let me write this diagram, let me draw this diagram in the bigger way, and let us go into this topic, energy band theory. It will make you to more clearly understand. Let us look about. So listen now. Now listen, there are two atoms. The outermost layer of each atom is merged. Outermost layer of each atom is merged. Listen now. So let us imagine about an electron which is over here. See, this electron is influenced only by this nucleus and whose velocity is fixed. Therefore, the potential energy of this electron and kinetic energy of the electron is fixed. Therefore, total amount of energy of this electron is fixed. Let us say this electron comes here. Now what happens? This electron is in the region of even this nucleus as well as this nucleus. Therefore, it experiences two forces due to one this and due to other one. Right? Therefore, it possesses two different amount of energies at a time. Therefore, finally the amount of energy this electron possesses at this point will not be same. Because here it is experiencing a force due to two nucleuses, right? If the same electron comes here, even the energy will be different because this distance and this distance is different, right? So these distances are varying, therefore amount of energy possessed by this electron in this region is different. So as the electron comes here, it will possess a different amount of energy. Here different amount of energy. Here different amount of energy. This is what happens. Again when it comes to here, it will possess the same amount of energy as much this. As like previous. So let me draw lines from here to here. See. Now you see clearly. When the electron is over here, it possesses the amount of energy of this energy band. When electron is over here, this possesses the amount of energy of this band. So there is an energy difference between these two bands. Right? I will draw here. energy bands. So when electron is over here, it possesses different amount of energy. When electron is over here, it possesses different amount of energy. So these are the lines are called energy bands. So in between these two valency layers, there will be literally thousands of energy bands will be there. So many energy bands will be there. So we are going to discuss about them. I hope you understand why electron possess different amount of energies when they are locating at a different places, right? So let us see now. Now these energy bands are classified into three categories. One is valency band, convection band, forbidden band. Listen carefully, I'll explain this. The electrons, though they are in the valency band, possess different amount of energies about their positions. Some electrons possess more energy, some electrons possess less energy, some are possess even lesser energy, but still all are there in the valency band only. And what about this? This is called convection band. So if any electron in the valency band wanted to become a free electron, that means this electron has to go to convection band. If any electron wanted to become a free electron, the electrons from the valency should shift to the convection band. So the electrons which are there in the convection band are considered as free electrons. And the energy gap between valency band and convection band is called forbidden band, or we also call it as energy gap. Right? So when I am talking about insulators, the energy gap between valency band and convection band is more than 3 electron volts. That means if you want to shift an electron from valency band to convection band, you are supposed to supply an amount of energy by using light or heat or any other method approximately equals to 3 electron volts or more than 3 electron volts, depends upon the atomic configuration of that atom. Now comes to semiconductors. For semiconductors, convection band, so this is valency band, convection band, and this is energy gap or forbidden gap, whatever you see. For semiconductors, I am talking about pure semiconducting material. For silicon, energy gap for silicon is 1.17 electron volts. For germanium is 0.74 electron volts. But when the same semiconducting materials are doped with an external agents, then energy gap for extrinsic semiconductors even be lesser than these values. Therefore, when you are looking about for insulators, energy gap is more, therefore you have to apply a lot of amount of energy to make them to move from valency band to convection band. When it comes to semiconductors, the energy gap between valency band and convection band is less. For pure semiconductors, it is 1.17 electron volts for silicon, 0.74 electron volts for germanium. But when I am talking about extrinsic semiconductors, the energy gap even be lesser than this. Therefore, you need to apply a small amount of energy to make the free valency band electrons to move to the convection band electrons. Let us look about for conductors. So for conductors, what will happen? So this is valency band, this is convection band. So if you observe, there is no energy gap. This is valency band, this is convection band. In conductors, valency band and convection band merge each other. Therefore, whatever the number of electrons are there in the valency band, will be the part of a conduction band. Therefore, you no need to provide an extra amount of energy to make a valency band electron to conduction band electron. I hope energy band theory is understandable to you. So once again I'll recall this topic just in 1 minute. According to Bohr theory, electrons in a particular orbit possess a fixed amount of energy, right? But when it comes to the solids, the interatomic space between the atoms are very less, therefore outermost layers of energies will be overlapped each other. So the electrons which are moving in the valency band possess different amount of energies, right? So based on that, there are energy band theory is developed. So basically there are three energy bands as per we know that. One is valency band, other one is forbidden band, and third one is conduction band. The electrons which are in the valency band are still a part of atom. The electrons which receive a sufficient energy based on the energy gap or forbidden gap. If the amount of energy received by electrons is equals to forbidden gap, then these electrons will move to the conduction band. So when it comes to insulators, forbidden gap is 3 electron volts. For semiconductors, 1.17 electron volts for silicon, 0.74 electron volts for germanium. If it is extrinsic semiconductors, even the gap will be less. When I am talking about conductors, there is no energy gap between valency band and conduction band. Therefore, the electrons in the valency band are the part of a conduction band. I hope energy band theory is understandable to you. If you like this video, please like the button, share to your friend, please subscribe to my channel, leave your comments in the comment box. Thank you.